Hello, this is Duncan, Dorset Woodland Blades. I'm just having a quick run round my new grinder. This is a replacement for my slightly older version. It's a similar machine, maybe the same guy, Alistair at Downland Engineering. However, this one's had all the latest bits he does on his new grinders, plus a few special modifications just for me. Basically, the main difference between the older style and the new ones is the new ones have one of these, which is the three-phase inverter, and gives you infinite speed control at the turn of a button. This also then has the effect of you don't need to have the pulleys. This is a direct drive, so the drive wheel here sits directly on the motor shaft, and as I say, the speed is controlled directly from the motor. This is also a three-phase motor, so we're using the inverter to convert single phase on a 13 amp plug through here, and generally these have a bit more torque and power. So on the modifications, what I wanted to do was get a lot more speed on the belt. That's the speed the belt is running at. One, to make it cut quicker, and two, actually, if you ask the manufacturers, the cutting speeds for these belts are a lot faster than we generally run. However, even at standard speeds, it's fairly quick at removing material and probably suits most people. So with that effect, after a quick chat with Alistair, he's come up with this. He's always pretty good to me. All my machines he make pretty much non-standard. As you can see, unlike most of the ones that come out of the shop, he's actually put some shielding on. I've removed a bit of it, which was over here, which was in the way. Generally this is ripping metal so fast it goes round the belt fairly easily. So what's different from standard? Well, the first thing you can't really see is the motor is actually a slightly different motor. It is a 2-pole 3000 RPM motor. As standard, he normally uses a 4-pole 1400 RPM motor. So the motor is already going at twice the speed at 50 Hertz. And to make that go faster on the speed controller for the standard machine, you can then overdrive the motor from 50 Hertz to 100 Hertz on standard, which gives you 2900 RPM. This 3000 RPM motor can only be driven to 60 Hertz, so only about 20% of its maximum, but that still gives us 3600 RPM, so we can get an extra 700 RPM out of the motor, which brings us up a little bit on the belt speed. However, the next main change is this, which is the drive wheel. The standard drive wheels, you can see here there's an older one, which is a solid aluminium one, is a 4-inch wheel. This is a 6-inch wheel, so that drives at 1.5 times the speed of this. The circumference of this is roughly 12 inches, the circumference of this is roughly 18 inches. So for every revolution of this we get 18 inches of belt movement, for every revolution of the other one we only got 12. So also you'll notice centre hub here, we've made this one removable easily, so you can actually change the drive wheel to a 4-inch or a 3-inch, or even a bigger one, which is an 8-inch wheel. To accommodate that, Ali's actually, if you can see here, put these bolts so we can move the motor mounting on the arm to take into account different size wheels to keep a similar belt length and not throw everything else out. Now, as standard now, Alistair normally supplies these with these roller wheels in polyurethane. However, he was a bit worried about the speed that this one was going at, so he's only allowed me to use aluminium wheels on here. He's also uprated the bearings. Normally these are held on with a 10mm bolt and bearing in the centre. These have been upgraded to 12mm, just again to take the extra speed and pressure. Other differences from my other machine, but are on standard now, is the arms are now made from aluminium, whereas my old one is a much bit thicker steel unit, which is also a lot heavier. The head on mine again is steel, but also bolted together in 2 or 3 pieces. This is single piece aluminium, so a few improvements on there, makes it a bit lighter and easier. Hopefully later on I'll get another arm with a contact wheel on here, because I do some hollow grinding now, and it's actually a very useful thing. So a quick look. There's a big on-off button on this. Then have a forward or reverse switch. This one doesn't run particularly well in reverse without major changing on the tracking. Speed control here will set between minimum speed and maximum speed. You can actually vary these. Obviously it's not recommended you take the maximum speed above the 3600 on this or the 2900 on the other motor. However, you can. This will actually drive a motor a lot harder than it's capable of taking, because it's designed for lots of different motors. So in here we can get into our programs. If we look at this one, this is the maximum speed that this motor can do. You can actually change that right up, but as I say, if it goes more than that on this one, we'll blow the motor. P2 is the minimum speed. It can be set to 0, so it will start from a standing start. I've set it to 400 at the moment, so but that's still a bit slow. You can still slow the belt, so we can change that up. 20, 30. There we go. So that's the minimum speed set now, and it will only come on. This is on a minimum at 500 revs instead of 400. There's a few ones here. 3 and 4 are the ramp up speeds, how long it takes to get to speed, and how long it gets to slow down. I've changed these on mine. They're standard, they're set at 5 seconds, which for me is a long time for a belt to slow down between belt changes. So I've changed it down to 2 seconds, which stops the belt a lot quicker. If you go below 2, you do get an error message come up, so I've left it at that at the moment. There's a few other settings in there you can play with, but I would recommend obviously reading the manual and understanding anything before you change any of the settings on this machine, because as I say, this box can damage your motor if it's set badly. So on stop, turn it on. There we go. Because I've set the speed in there, that's the 500 RPM that it's running at. You can cycle through. That's the amps it's pulling, 2.8 amps, because it's on tick over and there's no pressure on it. I've also got another parameter in there, belt speed. This means that the belt is doing 785 feet per minute. Okay. Now I use this generally, any of these multiples, and again if you turn it up, it goes up and down. As you can see, 500 RPM, sticking over nice and slowly. I've got on here a 36 grit heavy belt, designed for hardened steel. Now let's take it up slowly. (2,900-ish). This is the speed that you generally get now out of the maxi grinders on their maximum with the 1400 motors, and that's pretty good. Get scrap metal here. Not pushing too hard, but it takes metal off quite easily. However, (3,600 feet per minute). This was roughly what my old grinder was doing on its maximum one. Again, a bit faster. But unlike my old grinder, I can now lean on this a lot harder and it doesn't slow down. However, as you can see on the dot, we're only just over halfway. Now at maximum speed, which to me actually doesn't sound very fast because this is a much quieter machine. And I'm leaning on this gently with my left hand, which isn't the best way of doing it. There's pretty much no vibration, although this does make a bit more noise than a normal one does, because as I say, it's going a lot faster. So, I'll turn it off now, and if you watch, 1,000, 2,000, stop. It stops nice and quickly for a belt change. Okay, back again now. I've set up my table. This is an extended table I bolted onto the top of the 180 supplies. It's slightly different from the old one on my original unit, which was fixed square. This one's got an adjustable set of arms and you can move it about. I put it back pretty much where my old one was because I prefer grinding that way. I've set the table pretty much level and then set the platen square to it using a square. I've got an adjustable side on here which I can then set if I want to set any angle for blades for grinding faces. Okay, so we'll just round this off a bit. Alright, 2,900 feet per minute. Pretty well, nice and square edge. This is unhardened, which is why it's not sparking so much, and unhardened generally gets hotter quicker than hardened. Just turn it up a bit to maximum. Curve these quite easily. You don't actually have to push very hard on this. This is 7mm hardened 01. My laser cut blank, so this is just clean up profile. Fairly easily. Keep it nice and square. And if we want to change profile, we can. Let's come back out again. So as I was saying, this is a 7mm thick 01 hardened blank, so this is already 58-59 Rockwell. It's been laser cut, so all the hard work and grinding the profile is done. I just need cleaning up on all the faces and then the grind putting on it. Just a quick look. This is the other custom alley grinder I have. This is a profile grinder, so it lays on its side and it runs a KMG small wheel. This is what I use for cleaning the profiles up so the scratch pattern goes the right way. This one doesn't have any speed control. It doesn't need much. You can't go too fast because these two small rollers go far too fast for the bearings and they'll burn out. So there we have a profiled and hardened blank ready for the cleaning up on the sides. The grinds on. As I say, this is 7mm thick, mainly because at the time they didn't have 6mm in stock. So obviously you're not going to put a standing line straight on that because it's going to be far too thick. So I'll put one of my Flandy grinds on to thin it out, 25 degrees Scandi secondary, and it gives you a nice solid strong bushcraft knife. All the skeletoning takes the weight out. So okay, I use a jig to grind my bevels. Basically it's a piece of angle plate which is at 90 degrees. I can clamp the knife to it. I use a pair of mole grips, and then I can set the angle on here to what I want, and I can grind it, and it maintains at least a few of the degrees of freedom. Slight modification I've been doing recently, because I do again batches, is I've drilled and tapped a few holes in here of pins so that I can locate knives of the same type, the same angle, because on this I want to put a plunge line at this angle because of my scalloped front of my scales. So again, if I put that through that hole, rest it down, I can then just clamp it in place. You can see this, I've already marked and scribed 3 lines on the centre line, which is where the edge is going to be, and then one either side, which is where the primary grind will stop, which is what I'll do first. And that primary grind will go from there all the way back to the top of the blade on the spine here, and obviously that as that goes forward, this will distal taper automatically as this distance gets smaller. So at the moment it's set at 90 degrees still. So all I have to do now is bring it up now at the guess to start with. I'm going to go for 4 degrees, set on there. As you can see, just need to tilt it forward. Again, on this one we can either tilt the bed up or that bit forward. Let's try the bed on this one. Once shut up, I need to move this out a little. I'm still getting used to the bolts and spanners on this because it's different from my existing grinder, which I've got so used to doing. A couple of extra spanner sizes to use, which is a bit annoying, and I might change over. And as I say, this bit is new to me as well, so we're not going to get an exact match on this because I haven't calculated the exact angle. We'll work that out as we go. Okay, pretty much there. He says I'm doing it, see? Tight. Still think I'll get a flat one of these welded up square. Now normally you want to take a 45 degree chamfer off of this with a slightly older belt to help preserve the grains. This is a very slightly worn new one. We won't bother at the moment. And again, normally I'd be wearing a head mask because again it produces a lot of dust. You can see everything's supposed to be painted clean and white in here, and it's not exactly clean anymore. So let's start off. 2,900 standard, let's take it right up. touches the top here before it touches the line. Right, we've got the grind to the top of the spine, but it's still not quite got down to the line, which means we need to increase the angle and regrind. So a slight adjustment, technically speaking. As you might see, and it's hard to do a grind change, but we want to make sure that we can see when the grind gets back to the spine again. Again, I used to be quite good on my older system because I knew exactly how much to tap it. Okay, that's the 36 grit. We're pretty much down to the line on this side. It's just touching the spine there. So that's the main grinding done. The plunge line carved in. So quick belt change. As you can see, it is hot. I wouldn't want to hold my hand on there, but it's not overheating. It's a thick blade and the angle bracket does act like a heat sink. I'll put it in the water at the moment just to cool it back down again. Simplish belt change again. The colours on this particular make it a bit harder than normal. We'll change from 36 grit to a 200. This one's a Norax engineered abrasive belt. 300 did a Trizac one as well, which is pretty much the same thing. And even shorter because we come from America. They're 72 inch belts, not the standard 2 metre I normally use. Again, and a bit in speed on this one to start with. As you can see, I've got a black mark on here which is about 2 inches wide. Did you know at a belt speed? On flat out, this belt is going around here 14 times a second, 28 meters per second. I'll run this at about 3,400-ish. Doesn't need to be exact. Playing around, you can get used to what you're doing. Practice across.